Hey y'all, today we're going to be covering section 8.6, which is on thermal pollution. The learning objective for today is that you can describe the effects of thermal pollution on aquatic ecosystems. We're going to learn what thermal pollution is and how thermal pollution can impact the amount of dissolved oxygen in water. So we're going to first talk about the relationship between oxygen and temperature. Now, the first term that is good to remember is what solubility is. And solubility is going to be the ability of a solid or liquid or gas to dissolve into a liquid. In this case specifically, we're going to be looking at the gas oxygen and how well it dissolves into water. Now, when we are looking at water temperature and oxygen solubility, we are going to have an inverse relationship between these. So as water temperature increases, dissolved oxygen is going to decrease. And so this is an inverse relationship because as water temp goes up, dissolved oxygen goes down. So if we look at this graph here, we're going to see temperature, and as it increases and the amount of dissolved oxygen of the milligrams per liter, it is going down as the temperatures go down. As the temperatures go up. The oxygen goes down as the temperatures go up. Now, thermal pollution is going to be when heat is released into water. And we're going to especially be looking at the negative effects that it has on organisms living in the water. So one of the problems of thermal pollution is that just generally, heat is going to increase the respiration rate of aquatic organisms. It's known as thermal shock. Think of how you are going to be breathing faster as you are warming up potentially. We're going to be having that in aquatic organisms. If you were to put a goldfish in a tank and you were to slowly increase the temperature, you would watch it breathing more. Now, another problem is the fact that hot water also is going to have less oxygen in it. And remember that aquatic organisms, well, all living organisms, are going to need oxygen in order to do cellular respiration, and that aquatic organisms get this from the dissolved oxygen. And so as we are having less oxygen, because the water is heating up, this can lead to suffocation of the aquatic organisms because they aren't going to have enough oxygen in order to support the respiration that they need to do. So we're going to look at some sources of thermal pollution. Sorry, PowerPoints are way off here. Okay, so for the sources of thermal pollution, power plants are going to be using cold water from the surface or groundwater sources in order to cool the steam used to turn their turbines. So we are going to have warmer water then released into the local water sources. So they're going to be taking in cold water, using it to help cool down things, and then releasing some of that warmer water back out into the waterways. Now, we are going to see this from power plants, but we also see it with like steel mills and paper mills and then other manufacturing plants, because they're going to use the cool water to actually cool down their machinery. And then that warmed water is, again, going to be returned to local surface waters, which is going to be bringing up the temperature of those water sources nearby these mills. Another source of thermal pollution is actually going to be urban stormwater runoff, because that water is going to be warmer because of the fact that blacktop and asphalt are warmer. And so as the water runs over them, it is going to be warmed up, and then it's going to be going into the local waterways at warmer temperatures. Now, nuclear power plants are especially going to be the ones that require large amounts of cold water to cool the steam back into water. Because remember that our nuclear reaction is going to be putting off tons of heat. And so you are going to need to be cooling down all of that steam so that the water can then be recycled and used to cool the core reactor. So this is why we're going to see our nuclear plants usually next to like big rivers, because they're going to be requiring tons of that cool water. Now, cooling towers, which you often are going to be seeing here with nuclear, are going to be used to actually cool their steam water back into water and to hold their warmed water so that it can actually be cooled before returning to local surface waters. So cooling towers are going to be a strategy for actually preventing thermal pollution. So as you're getting this hot water coming in the cooling towers, it's actually going to cause the steam to condense, it's going to cool, and then it's actually going to then potentially be released after it has had a chance to cool down. So this is standard in nuclear power plants. So for example, if you get an FRQ question where you're being asked to talk about like ways that nuclear power plants could decrease their thermal pollution, keep in mind they already have cooling towers. So saying adding cooling towers would not be something that would be beneficial for nuclear power plants. However, you can optimize these towers so that they're actually better at preventing thermal pollution. So for example, they could hold it longer before returning to nearby surface waters. Because right now they hold it for a while, but not necessarily to the point where the temperature gets to the exact same temperature as the local surface water. So they could hold it longer and longer in order to ensure that the temperatures are going to be the same before releasing it so they don't get thermal pollution. But cooling towers are going to be beneficial, especially if we can do them even better. And here's going to be your practice FRQ, where you will practice the suggested skill of explaining environmental concepts, processes, or models in applied contexts. So what I want you to do for your practice FRQ 8.6 is explain how an increase in nuclear power generation in a town may lead to a decrease in biodiversity in nearby aquatic ecosystems. So that will be your practice FRQ for 8.6, and those are your notes on 8.6 about thermal pollution.